The introduction is great. It was really generous, but also it really sets up the beginning of the talk. So I can just say, I think without really any controversy, that this is a moment of crisis. And it's maybe belated, but we realize that in the pandemic era, but also politically across the globe, we were recognizing the difficulties associated with AI in particular for social and political life. So it is belated, but I do want to say then that we're in the middle of a crisis, which, as Reinhard Koselleck wrote back in 1959, we're at a decisive turning point. And I think even looking back at Koselleck, even though he was talking about the opening of the Cold War, he also pointed to technology, which is to say that technology of communication has made us all omnipresent to each other. And this is something that is only like more powerful with contemporary digital infrastructure, to think about that. Now, we know that Koselleck was very much influenced by Schmidt. And Schmidt, after the war, was also thinking about this transformation in the role of technology in the political and social and economic sphere. And well before Latour, Schmidt had these amazing reflections on the way that this omnipresence of a technical system is actually contributing to making the human less a kind of independent figure than simply a prosthesis of a complex technical apparatus that is also at the same time social. And he tied that even to the most dangerous technical systems, which is to say the nuclear industry of the Soviet Union and the United States. So this is something that Schmidt was interested in even in his early work on sovereignty, as Danilo mentioned. He was alluding to the fact that since the opening of classical political philosophy with Hobbes, the state had become in some ways part of this machinic view, that the system is something that runs by itself, and that the humans in some ways are integrated now into the machinery of operation. So in some ways we could say that Schmidt, after the war, was already pointing to what would become true with what we call a cybernetic vision of planning. This is the famous CyberSyn system for the Chilean economy. Failed, but you can at least see the ambition in the room. Stafford Beer was the architect of this system, which we can see in its full glory here. The Soviets had planning computers analogous to that. And to leap through a lot of the history, we can say that today we're at a condition where maybe less is planned centrally in the way that the Chilean and the Soviet experiments were, but that globally we're living in what Bernard Stiegler has called the automatic society. And the point here is to say calculation prevails over what he calls all other criteria of decision-making. So we have become integrated into systems that in some ways prevent what we might call genuine decision-making. As he says, we're moving from not simply artificial reason, which we've accepted for some time now, but where administration, law, will, decision in general has become automatized. Now, what does that mean? That's where we want to kind of understand what's at stake there. So I think what Schmidt wrote in 1929, we could now repeat in 2021, which the present century will only be understood provisionally as the century of technology if we think again of the digital infrastructure. And Schmidt's challenge was to say, how do we restrain it? I mean, that's the question that we seem to have today. We're in the middle of an unprecedented revolution in all spheres of life brought about by AI and the digital. But how do we restrain it? We have to seek, in some ways, a new order. And this is what we need to do instead of to see in technology the possibility of an escapism. So rather than landing on the moon, which we ended up doing, we're landing on Mars. I can't help but bring Elon Musk into the equation here, because that's exactly, I think, indicative of this challenge that Schmidt is giving us. How do we reorder ourselves to restrain technology on the earth and not to think of what we call a Silicon Valley solutionism? Okay, so where does this come from? One of the problems that we have, and that Schmidt was already alluding to, is that automaticity of decision is part of the history of thinking about human intelligence and human cognition that, again, begins with the computing era and the cybernetic era, which is to say that the human can be understood in terms of a machine. And this was something that these figures understood to be a historical problem, is that if we're trying to understand the brain, we're trying to understand the human as a kind of intelligent machine, we usually look for analogs to the kinds of machines that we are contemporarily familiar with. So as they say, Descartes could look to clockworks and automatic fountain technologies of automata to understand the brain and the nervous system. But of course, in the modern era, the machines were information processing machines. And we can see here an early example from cognitive psychology. But the most perfect example would be in the realm of artificial intelligence, where, as in Newell and Simon's really influential work from the 60s through to the 70s, there's an exact parallel between the computer and the program and the human nervous system and the brain and its capacities for intelligence, essentially through the medium of what he calls, or they call, elementary information processes. These are identical despite the differences in hardware. So this is essentially, I think, a theme that is central to the emergence of cognitive science and neuroscience in our period, which is to say, any scientific theory of the mind has to treat it as an automaton. Otherwise, it's not scientific. And I think even though the formula seems crude, maybe cruel as well, but crude, it's a challenge. What are the alternatives to understanding the mind in the 20th century and the 21st century if we don't think of it as it's some kind of biological machinery? So this has led to what, only with some irony, cognitive scientists have called the unbearable automaticity of being, which is to say, the defamiliarization of our own will to the point where we can call it simply an illusion, that all real intelligence and cognition is being processed unconsciously by the brain as an analog of a computing device. And that's exactly how the brain is understood today. We understand the brain through the most dominant technologies of the day. And today, it's not simply the computer as a technology, but actually, I would argue, machine learning as a certain kind of intelligent system. And we can see this is a pretty good example of how the cognitive subject can be reordered as essentially a system of machine learning, error correction, and prediction, both in the autonomic world and the world of action. So machine learning, as you know, can take different forms, but basically it's the use of artificial neural nets, models of neurons, that can be organized to go from many, many inputs. This is just a description of a deep neural network, but these parameters could go into the millions if you want, in order to be organized to produce certain outputs, which are predictions. These are prediction machines. So there's deep learning, there's variations like convolutional neural nets where features are pooled within these deep learning networks, features like image features and so on. And the most recent development are called generative adversarial networks, where we have two machine learning systems sort of competing with one another to discriminate true and false sets. In other words, to predict whether something is truly a true image, a true statement, or a false one. And again, error is very important here. So the brain, strangely enough, can now be understood, is being understood on the basis of these artificial neural network theories, which is to say, as a Bayesian prediction machine that essentially is organized like deep learning systems. And this is now becoming sort of settled as a new paradigm within both cognitive science and the neurosciences, a field called predictive processing, also called predictive coding. And it was developed, in fact, by a collaboration between the brain scientist Carl Friston in London and Geoffrey Hinton, who developed deep learning as a theoretical possibility. And we can see from the beginning, the brain and this deep learning system were both influenced by one another. The most recent philosophical explanation is by Andy Clark. And you can see that the idea, again, is all about generating models, producing perceptions, and then what is called backpropagating error when the predictions fail. So what we have is the idea of both the human and the computer generating a model of the world and then paying attention only to errors in order to fine-tune the prediction for the next set of data. And again, we can see the exact parallel when we have, say, Friston's perception hypothesis as essentially a forward prediction and backward propagation of error through the system. So I will use this one quote to indicate, I think, a vast number of both informal and formal theories of intelligence that emphasize how true intelligence is essentially mapped onto this machine learning paradigm of intuitive inference that is actually the product of millions of parameters being organized through artificial neural nets or real neural nets in the brain to produce what is called common sense reasoning or intuitive understanding. This is the famous article that introduced deep learning theory in Nature in 2015. Okay, this was all very exciting in 2015, but I think since then we've seen the failures of prediction that can't be so easily back propagated, most famously with the early efforts at machine learning identification of and classification of images, where famously Google made this extreme fail. I won't go into this work. There's some amazingly good work on this this problem, especially Sophia Noble's recent book, Algorithms of Oppression, which shows how both the algorithms themselves, which are often very opaque, but also the data sets are sort of riven with all of these kinds of biases and prejudices that make the use of them very problematic in a social sphere. I just would add that this exact same problem, as in not just simply the problem of bias, but the problem of predictive intelligence and bias, is also something that work in the neurosciences as well, which is what we might call the dangers, let's say, of intuitive and immediate reasoning of the sort of unconscious production that dominates cognitive science today. So in response, and there's many different versions of this, in response, there's been a kind of recent emphasis on controlling AI, essentially, in the research centers. The major universities have something like Stanford's human-centered artificial intelligence, which is to say AI shouldn't be bad. It should be collaborative, augmentative, whatever that is, and enhancing to human productivity and quality of life. And the platitudes and sort of vagueness organize a lot of these institutes. There's one at Berkeley, Human Compatible AI, the Now Institute, AI Now at New York University, and there's many others at Harvard and wherever. The way I would want to sort of frame this is to say that what's involved in a lot of these reactions is to take back decision, to make human decisions instead of machine decisions, which is to say that there's an effort to take over the automaticity of decision, which is exactly what we want to think about the question. Because of course, in the humanities and the social sciences, this idea of the human is very problematic. Decision is a problematic term that we will see, as I'll try to show, is very much related to the human. And just as a kind of shorthand, we can say, there's no question that the critical humanities and social sciences have shown us that the human is structured as a historical and contingent construction. And whether we're looking at Foucault or Butler, Bourdieu, Donna Haraway, we can see that the stability of the human is put into question. I don't even have to, I think, mention that concepts such as justice and fairness that circulate around the ethical AI movement have been contested since at least, obviously, Plato, and we could probably go back further than that. So what I want to do then is to turn, because this is the moment of crisis and we're talking about decision, to turn to the problem of decision. And for that, I hope I don't have to apologize for going back to one of the best theorizations of political decision, which is Carl Schmitt's Political Theology from 1922, and the famous formulation, sovereign is the one who decides on the exception. So what I'd like to point out here is, first of all, simply the etymology, just to remind us that decision in English and in French comes from the Latin meaning to cut, which you can see much more clearly as well in German, which is to separate, that the decision is doing something, if not violent, at least disturbing, disturbs something. And the exception has the same kind of quality in English and in French to take out quite literally in Latin, and literally the same thing in German. So with a decision on the exception, we have this dual movement of both something being taken out of the norm and then having to cut in order to make a decision in that situation. Now, there's a lot to say about Schmidt and political theology, but I just want to point out a couple of things that will take us in a certain direction, which is this. As Schmidt says, the decision, if it's a true decision, that's cutting and taking something out, is freeing itself from all normative ties. And whether we think that's good or bad, I think this is a really important dimension of a genuine decision. It frees itself from norms. And in fact, it's even stronger. The autonomous moment of the decision means that the norm is destroyed. And that's because we have an exception only because the norms have failed. And whether these are legal norms, as Schmidt is talking about, or more generally problems of normative order, the idea is that the exception is a moment when norms have failed. And the decision then is made in a condition of what he would call anomic, chaos or disorder. So that's the first thing I'd like to mention. The second thing is that Schmidt aligns this movement of decision with what he calls life. And that's very much in tune with the life philosophy, Lebens philosophy of this period. As he says, the exception shows us the power of real life, and it's breaking through what he calls a kind of mechanical repetition that is uninteresting and clearly without this capacity. Now, the reason I want to mention this, the norms and the failure of norms, as well as the quality of life, is that this was not an unusual concept in this period, is to think about life itself as in some ways analogous to these political situations. Walter Cannon, who's famous for introducing the term homeostasis into biology, but also collaborated with Norbert Wiener in cybernetics, talked about these states that he was studying, shock and other extreme conditions, pain and so on, talked about them as emergency functions. In other words, when the body can no longer survive normally, it goes into a whole new kind of regime. And that regime will keep it alive by, in some ways, transcending the norms of normal life and putting himself into some kind of emergency condition. And he did not shy away from the political valence of these terms. And you can see a kind of Schmittian tendency in Cannon's thought, where he thinks about the body as being imperiled by enemies and needing to go into essentially a state of exception to render the organism more effective in a contest which may issue in either life or death. So the point there is to say that at the very minimum, the norms of life need to be transgressed in order for the emergency situation to be dealt with. Now, this question of life and the structure, the same structure, also appears in one of the most famous and influential books in medical philosophy and biology is Canguilhem's The Normal and the Pathological. I apologize that these are in French and I didn't have time to translate everything into English, but what I want to point out here with Canguilhem is that the normal for him is defined in terms of the conditions. So whether we're talking about a mutation in evolution or whether we're talking about a pathological form within an organism, we can only think of things as being normal in relation to new conditions. So if the conditions change, the norms change, which is to say a mutation, which is an error, can in fact turn out to be the origin of a new form, which is a new form of life. In other words, establishing a new norm. So we don't want to think in terms of past forms, but we want to think about how norms transform themselves in terms of new conditions. And this is particularly true when we're thinking about what life actually is for Canguilhem. What we're talking about is that norms here are not given for once and for all. What we mean by normal and pathological changes in terms of what are the challenges or crises that a particular organism is facing. So whether it's an anomaly, a pathology, a mutation, what we're talking about here is how life can take new forms. Other norms of life are possible. So we don't have a disease and then return to health. The disease is in fact a new set of norms on the way to a new kind of health. And this is really how he wants to define life. Life is not a set of norms, but the normative activity. And if you know Schmidt, there's an echo of this quality in Schmidt too, the normativization capacity of sovereignty, for example. So to be normative is to institute, to found new norms. That's how Canguilhem defines life. Okay, so when we think about the automatic then and the machine and the cybernetic, for example, in Norbert Wiener's 1950 book on the human use of human beings, Schmidt owned a copy of this, by the way. There's an attempt to kind of take over this language. The machine is capable of decisions, according to Norbert Wiener, that produce zones of temporary organization in a world that is driven by entropy. There's an attempt to kind of bring these two discourses together. Schmidt was not convinced of this, writing that no perfected cybernetic apparatus would ever be capable on its own terms, in other words, without the intervention of the human, of asking this question, who decides? What is a decision? However, if we turn to another founding, I don't want to say father, that's terrible, founding figure of AI, which is Alan Turing, I think we can actually tease out a quality that Turing wants to identify both in the machine and in the human that might actually have something to do with this question that's being raised by Schmidt and Canguilhem and others in this period. So Turing, as we know, both developed the computer and developed the first theorizations of artificial intelligence in that famous article. But in some other work, it's more clear that what he was interested in terms of the parallel between the human and the machine is not what you might expect. He likes to think about interference. How is it that a machine could change? The only way it can change in an interesting way is if it was interfered with, because that allows for actual modification, for genuine learning. The machine does not remain the same. But whether that makes sense in terms of a machine, especially a computer, is one thing, but to say as well that a human being is a machine that is subject to very much interference, then we have a much more strange parallel. And the nexus of this parallel was Turing's idea that the human cortex, which distinguishes our brains from others, is what he called an unorganized machine. The cortex of the infant is unorganized, which means it only actually does anything once it's been suitably interfered with, which is to say, if it learns. And in fact, it would be useless. It would be an automatic machine that doesn't do anything if it wasn't organized. And we can think here of like the wild children's stories from the 18th century of humans that could not speak or think supposedly as humans are capable of in society. So the point here is to say the open computer and the open human cortex are interfered with in order for them to become interesting. But what he wanted to retain, I think, this is what I've been working on, is some role for the original plasticity of both the brain and the computer to be maintained within the machine itself, whether the machine was the brain or the computer. By this axiom is that if you learn a process, they can never be 100% automatized. There's always the possibility that they can be unlearned. So to summarize some of the work that Turing does here in these other essays, plasticity and discipline gives us organization, the norms of thinking, of behavior, and so on in society. But initiative for Turing means to stray from the norm. And to do that would be to, in some ways, deploy what we might call the residue of plasticity. And there's this one comment where he says that our task is to discover the nature of this residue, the residue of openness as it occurs in human beings, but to try and copy that in a machine, which is a very strange and difficult concept. So we could think more about that, but I do feel like it pays off in his major work from 1950 on artificial intelligence, where he actually doesn't use the term intelligence very often, but when he does, he defines it as he does here, not in a positive way, but as a departure, a deviation from disciplined behavior. And it's the disciplined behavior involved in computation. So what he's really arguing here is that intelligence for a machine, like for a human, is to deviate from the norms, even the computational norms, in order to provoke something new, in order to actually try something that hasn't been predicted from the computational organization itself. And so he's trying to infuse the freedom of life, you might say, in the machine that we already see in the human brain with its residue of plasticity. Now, again, the cyberneticians were trying, successfully or not, to integrate some of these ideas into their conceptualizations of automatic machines, especially learning machines. So Gray Walter, for example, power to learn implies breakdown. And I could do more on this, but I'll just give you this one quote from Ross Ashby, the British neuroscientist, psychiatrist, and cybernetician, with trying to speculate about how we could give machines the possibility of new organization by allowing for them to break. In other words, if we're going to be able to break out of equilibria that are no longer successful, we need to literally break the machine. And what he meant by that is not smashing the machine, but thinking of it as, say, with the neurons, having to go into waiting periods where they're no longer productive. In some ways, you could say the machine is constantly breaking down because neurons go offline, and when they come online, new organizations are generated. The point for me, though, is to say that this concept of novelty, of new norms, new equilibria, is something that is being pressed upon on both the artificial intelligence side, cybernetics, and in the political sphere. And last, the example from von Neumann, who was extremely interested in error and organic plasticity, as someone commented on his paper from the famous Hickson Symposium in 1948, that a nervous system has to be able to be both relatively stable, in other words, follow norms in order to be successful, but also to account for its operation under abnormal situations. And this is the key. How do we understand a machine system that can go from both normative behavior as well as into situations of the abnormal? Okay, well, I want to leap then to the origins of contemporary machine learning, deep learning, which is artificial neural net theory that gets rediscovered, reamplified, reborn in the 1980s. And there's a 2-volume set of essays called Parallel Distributed Processing that is really kind of iconic in this particular movement. So what we have here in parallel distributed processing is something that's familiar to us now, which is the idea that a machine network could generate a model of a world and predict the future of this world, and also fine-tune its predictions through error by reorganizing its model of the world. So this looks a lot like von Uexküll's function circle, and it would flow automatically. It's an automatic prediction machine. So one thing I just wanted to point out in this opening of the modern machine learning era is that they already were recognizing, and Geoffrey Hinton is a young researcher here involved in this work, already emphasizing that this sort of automatic settling into solutions doesn't seem to capture what makes humans so intelligent, the ability to kind of do something that's more active, let's say. And what they say is that one of the things that seems to be endemic to the human situation is the ability to, as they say, create artifacts, to create physical representations that we manipulate on the page or in 3D to answer problems. And moreover, what makes us so intelligent is that we can internalize these kinds of external artifacts and imagine them and use certain kinds of processes that would not simply be possible in the closed loop of the prediction machine. And why is that? Because the external environment has in some ways invaded the mind and become an extension of it. So rather than simply having a model of the world, we now have the idea that an object in the world, an artifact, an artificial tool, let's say, an implement, a diagram, a symbol, can be internalized and reorganize the machinery from within. Now, they also recognize the very deep philosophical problem of, well, how do we invent external representations? How does that automatic prediction machine interrupt itself, deviate from itself enough to invent an artificial artifact, if that's not an oxymoron even, anyway, or a tautology? It may be the process of inventing these representations is the highest human intellectual capacity, is what they say. And they displace the origin over to culture. Usually these are provided by culture. Now, what's interesting is this is a period, actually, the 1980s and 1990s, with a lot of interesting work in evolutionary psychology, trying to understand the origin of culture as, in fact, the break from biological evolution into something new, cultural evolution, and the importance in that turn, which is kind of a threshold, not an evolution. The threshold of culture is the tool and language, these sort of possibilities of artificial symbolic representation. Now, one of the best syntheses of this kind of approach, a very philosophical one, is Wagerall, who's a prehistory anthropologist. His work on gesture and speech. I won't get into all the details of the argument, and I could explain more if we need to, but the basic idea is that we have to think of this threshold between the biological and the cultural as taking place over a long period of time, even though it is a threshold. When the hand is liberated by our bipedal ability to stand on two legs and to liberate the hand from grasping and locomotion, the brain and these primitive tools that the hand is now able to make co-evolve. The tool evolves with the brain, involves also the kind of manipulation of the hand. These things all co-evolve in order to produce this strange creature, which is the tool-making social creature that is the human being. And what Wagerall emphasizes is that the brain does not evolve to become smart in the sense of having a capacity, let's say, for invention or a capacity for language. It actually evolves to be open and plastic. It becomes, as he says, super specialized in the skill of generalizing, which is a way of saying it is capable of synthesizing and doing things that are not automatic, but are due to its open and plastic structure. So this is the way he describes what happens in this transition from the biological to the cultural, is that our evolution now is oriented to placing things outside of ourselves. In other words, our gestures, our experiences, our thoughts, our capacities are exteriorized into tools and also to language. And the key here is that these tools and language, social organization, these are all systems that take on the memory of an individual nervous system and allow it to be transferred to other nervous systems. So we can think of these complex technical systems that allow us to survive in nature. They also rely on social systems, because only through sharing of memory would any individual know how to operate the kind of technologies and to survive. So these all depend on artificial memory. This argument is refined in the 1990s by Bernard Stiegler in the first volume of his trilogy on techniques and time. And the basic idea that comes from Wagerall is that it's only by exteriorizing thinking into tools, into these kind of artificial implements, these artifacts, that we're able to pursue life. Human beings survive by using non-natural means, tools, which is to say, artifacts that are in some ways organized mechanisms rather than living beings, although we are, of course, a living being. Now, the argument that he makes in this text is that we have to think of the human then in three different ways. Yes, we're still organized by the genes. Genetic memory is important to the way that we operate. We also have epigenetic memory, which is to say the individual experiences that we have that get stored in our brains. But as humans, unlike animals, we also have what he calls epiphylogenetic memory, which is just a word to say that we have artificial memories, which is not simply that they're stored in artificial forms, but that we, in fact, can have experiences that are not our own. And that's one way to define the human for Stiegler, is that we live in a world of ideas, thoughts, experiences that are not our own. And in fact, the only reason that we can take them on as our own is because we understand them and organize them in terms of artificial symbolic representations or artificial tools. So the upshot of this is to say, there is no interior experience of intelligent human cultural tool-using life that is then projected outside into the world and shared with another. It's that the human as a cognitive intelligent being is defined as in some ways constructed through this process of exteriorization and interiorization, which is to say the tool invents the human for Stigler in a very profound way. Now that has a lot of post-structuralist complexity to it, but I just want to take this at least as a point that Stigler is making, and we can discuss it later. But this is really critical, is that what he means by human thought is that it's artificial. Intelligence is artificial from the very beginning. Sequences, organized thinking, these are all unnatural. They're not necessary, whereas the animal is a kind of prediction machine based on what we might call the kind of paradigm that is coming to be dominant in machine learning. And this is just my way of sort of understanding that, is you can say that with a tool, when we look at a tool, even a simple tool like a flint, we can see at once the past. It's sort of like the fact that it was made in the past. We can see that it's an anticipation of a future that's not necessary biologically. In other words, we can see that we could use it to skin a deer that we've hunted. But we can also see at the same time past, present, and future in the organization of the tool. In other words, it's a sequence. You have to know how to make the tool, and you have to know how to use the tool. So there's embedded in that object is temporality, memory, anticipation, possibility, and not prediction. Because in order to understand this object, one must be immersed in some ways in this process of interiorization and exteriorization. Okay, so clearly, if you're in philosophy or related disciplines, you can see that Stigler is drawing a lot here on Heidegger. And I don't want to scare everybody with this turn to Heidegger. I want to keep it really quite straightforward and say, thinking about tools, in particular simple tools like the flint or Heidegger's hammer, what Heidegger argues is something I think that's very much in tune with Wagerall as well as Stigler in Being and Time, is that it's the tool, the social environment, our glasses that we're wearing to see the world, they all seem natural and seamless to us. And we predict futures based on the kind of automaticity of the use of these tools. It's when they fail, when they no longer perform according to our expectation, the predictions that we're making based on them, then the tool reveals what he calls worldliness. And that would be equivalent to what Wagerall and Stigler mean by the world of symbolization, of construction, of the non-natural organization of the world. And that's both social, it's both psychic and cognitive, and it's also obviously technical. So that failure is what reveals the contingency of this particular state of being. For Heidegger, as we know, we're historical beings, which is to say, we're defined by alien forms of thought, the thought of others that come before us. And that thought is always the foundation for projecting a future that normally follows pretty much a kind of seamless pattern of anticipation that I would say is very much akin to what we would call prediction. It's only in the failure that something new happens. And it's the failure that introduces this kind of Heideggerian gap, where we could call it more a chasm or an abyss, which is when we recognize through the failure of the tool that we are historical beings. In other words, we are who we are not, we are others, but at the same time, we recognize that we are not that thing. So this is the kind of Heideggerian moment where we understand that our existence is something different from our essence. And that throws us into great confusion. Thrownness is a condition of disorientation because we can no longer rely on the automaticity of our historicity. And this is the space for what Heidegger will call, decision in the Beitrage zur Philosophie, this idea of the split, the cut, to emphasize that etymology. So this is what happens when tools fail And humans begin to wonder about this world that we are and that which we are not. We're in the midst of what we are not, although in some ways we are defined by those things. And then there's the shock, this abandonment. The main thing I want to point out here, though, is that we come back to decision with Heidegger, because it's only with the failure and then the recognition that both our technical and social life and even our perceptual condition is something that is not automatic, it's not necessary, it can be interrupted, that we have something like decision. And decision, therefore, is not some sort of like human capacity that is simply part of our makeup. It's not a procedure, definitely not something that could be mechanized for Heidegger. It's actually this moment of separation. And we don't need to go into all the details here, but this is just what I would emphasize again. The decision refers to this openness of a realm that is sundered, the splitting of the past, the present, and the future, and the disruption of the seamless automaticity of that relationship. Now, what Heidegger wants, obviously, is to think of that open realm as now an opportunity for something to happen, where something will not come from, some sort of situation that is human, but where something might be unconcealed. So in this moment of undecidability, decision will be this chasm that might offer a glimpse. I don't know. I'm not going to talk like Heidegger at this point. It's just, we can at least say for him, it puts us in the condition of a decision that might open us to the revelation of something beyond the human. And that's what he calls the event, this opening, unconcealing, and so on. Okay, not to dismiss Heidegger at all, but I think what Stigler wanted to say about Heidegger, if we just think again about the sort of simple framework here of the use of tools and the need to understand how we use them, is that what Heidegger didn't want to recognize is that all of the memory that allows us to act as historical beings in the world of worldliness is conditional on artificial memory, what he calls tertiary retention. So that means that, again, coming from Wagerall and coming from Stigler as well, it's not that human thinking could ever be separated from its technical component. And in fact, at the very heart of Heidegger's theory, temporality, this past historicity that flows through a present to an anticipated future, according to Stigler and Wagerall, that temporality is an artificial construct that is the implication of the tool. It's only with tools that we are able to even think in terms of that relationship between past, present, and future in the way that allows it to think of it as a contingent organization dependent on a kind of mechanical condition. The reason I mention this is that it puts different pressure on what we mean by decision. For Heidegger, it's a recognition of the radical undecidability of this chasm, this space of abyss. Whereas for Stigler, this space that opens up maybe with the failure of the tool does not take us away from technology. The decision still has to be framed in terms of not human versus historicity and tertiary retention, but actually decision as something that takes place between and within the techno-human ensemble, which is getting closer to what's happening today. So the challenge then would be to think backwards now again into historicity and contingency and so on. For Stigler would be, how do we evade in this moment of decision the normativity of both the technical and socio-political forms of discipline? If we think against Heidegger that it's simply not possible to say in the moment of recognition that somehow we have escaped from the technical. In fact, we're still in the normativity of the technical regime, according to Stigler. So thinking with Turing, how would the mind deviate from norms when they condition even this experience of this rift in time, which is what Heidegger calls the undecidable? Well, that is the challenge. I mean, I think this is the challenge that Stigler has to face. But one of the ways that I think he answers that challenge is to say, this moment of event is always happening whenever a human being reanimates, let's call it the dead thought that is stored in the tertiary retention, the mechanical artifact, the printed book, the tool, and so on. It's always an event, which is to say unpredictable, something where something uncertain happens. Because whenever a human does that, it's never simply an enclosed process. The human being is always a living being, a living body, and it exists in a social organism, which has multiple systems and multiple layers that aren't always congruent. So for Stigler, whenever a human being thinks dead thought, yes, it's conditioned by technicity and it's conditioned by historicity, but it's also always an event. And I think that helps for Stigler to understand how it's possible for human beings to create and to be open to unpredictable things. The problem is not simply the Industrial Revolution and modernity, as it was for Horkheimer and Adorno and others, but for Stigler, the specific pathology of the digital era. Because what he's arguing with his work on the digital, and again, I just have to be brief here, is that these events of individuation that take place when individuals who are complex bodies and social creatures are reanimating past thinking, past experience through tertiary retention, this is being short-circuited by the digital. And the argument is that because the digital is so intimately connected with our nervous systems, it's short-circuiting the individual, and it's definitely short-circuiting what he calls trans-individuation, which is to say many of these processes that we go through as social beings are done with other people and have to be done with other people. We learn and we co-individuate, but this is all being short-circuited. Digital infrastructures are artificial memories, artificial, let's call it artificial predictions, and the system is so dependent on calculation that it must eliminate inconsistency, which is to say, to get rid of any possibility of deviation, which is to say the destruction of decision. And this is essentially what Stigler is arguing, I think, in his work in the late 2010s up until his death, which is the short-circuiting of human eventness, which is thinking. This is something that sounds Heideggerian, but in fact, it's very much about this contemporary era. To put it in simpler terms, and to borrow some Habermas here, we can say that the public sphere is now conditioned by certain kinds of digital infrastructures, Facebook, Twitter, and other more complicated ones possibly. The private sphere is being conditioned by the digital, what Stigler called the proletarianization of the consumer. But even Habermas's intimate sphere is tightly wound with the digital infrastructure. And because these are all digital infrastructures, they can all be integrated at the level of computation and produce from digital traces machine predictions that push human beings in directions that mediate all of these different arenas into one super system. Our digital double, as it's been called, is somehow created within this matrix of both public, private, and intimate participation. So the problem then, as Stigler understood it, was that if we now live in a digital infrastructure where calculation is what marks anticipation, it will always be formalizable and describable, but it will never be open to what we would call the unexpected, the unpredictable, the not yet there, something that we could imagine to be the case, but is not necessarily the case. Which is to say, we must, in some ways, deviate again, to come back to something Heidegger wrote, in order to exemplify this capacity for creativity and for novelty that marks both human life, or life itself, as Canguilhem would say, and especially the life of thinking. So in order to think deeply, we must err profoundly. And that's exactly the opposite of what the machine learning paradigm is devoted to. As we see in a famous article now from Ruhr and Burns on algorithmic governmentality, the whole organization of machine learning is to evade the unpredictable. Something that is literally outside the system or that puts it into crisis. the error is something different. It's digested by the system and simply made into a new prediction. Now, this is absolutely critical, and this is where I'll end, because when we're talking about machine learning, we're not talking simply about prediction, and the evasion of the unpredictable is a kind of, scholarly question. When we look at the way that analytics describes both human cognition and these digital infrastructures, we go from predictive analytics to something called prescriptive analytics. So when we predict something, we can also make it happen. Now, for Stigler, that was taking place all the time in the digital sphere. Your digital traces are not only predicting behavior, but then making you behave according to the prediction by seeding your nervous system with certain kinds of addictions and habits. But even more deadly would be the idea that we can make predictions true simply by creating the conditions of avoiding the true and interesting unpredictable error, as opposed to simply the error of calculation. As some of you may know, once you've killed the terrorists who've been predicted to be terrorists, it's very difficult to prove that you aren't a terrorist. So they confirm the prediction, they make the prediction true. This is also the case in algorithmic justice, where once you deny parole to somebody based on an algorithmic prediction, that person never has the capacity to show a potential transformation of behavior. So this is the condition that we're in the 21st century. The destruction of decision, literally, and decisions that have become automated. This is my last slide, is the hope that we would have is that despite the intense automatization of the human brain, as Turing already argued and Stigler picks up on here, the brain is a machine that is capable of dis-automatizing itself. So that's the piece of hope that I'll end with. Thank you.